Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626, Unit 4, Electric Traction. Difference between 25 kV AC system and DC system. So the point of comparisons are voltages used to transmit power. For DC system it is less up to 600 volt. For 25 kV AC system it is more up to 25 kV. Second point is the current requirement. It is more and it is less in 25 kV AC system. Voltage drop in line in DC system more due to large current, and in 25 kV AC system less due to less current. Then the cross section of overhead conductor, it is more in DC system and in AC system it is less. Requirement of special equipment in the substation. So the special equipment in the DC system is the rectifier, and in the AC system it is the frequency converter equipment. Next is the distance between the substation. So less due to the more voltage drop in the line, and it is more due to the less voltage drop in the line. Power handling capacity is less in DC system and it is large in the AC system. Starting efficiency in DC system it is less due to loss in the starters, and in 25 AC system it is more due to less loss in the starter. Then the cost of substation is more due to the rectifier, and in AC system it is less. Then erection work and maintenance of the overhead equipment, it is more in the DC system and it is less in the 25 AC system. And cost of the overhead equipment in DC system is more, and in 25 kV AC system it is the less. Block diagram of AC electric locomotive. Overhead catenary. It carries 25 kV AC supply. It is kept at a definite distance from the roof of the locomotive. It is made up of coated steel. Pantograph, it is a current collecting gear. It makes sliding contact with the catenary at the optimum pressure. It collects AC current and sends it to the transformer in the locomotive. The pantograph contact material is made up of metallized carbon. Next is the air circuit breaker. It is a protective device. It protects the current from the abnormal working condition such as overvoltage. Transformer. We use a step-down transformer with the tappings on primary side is provided. The secondary of transformer is connected to the rectifier unit. The AC supply required for the auxiliaries like fan, light, and pantry is directly taken from the transformer secondary. Next is the rectifier. It converts AC to DC. DC supply is needed for DC series motor, which drive the locomotive. The output of the rectifier is the pulsating DC. Hence, DC filter is needed. Filter. A smooth DC is obtained by using filter circuit. It converts pulsating DC into the smooth DC. Traction motors. These are provided below the chassis of a bossy or the loco unit. These are connected to driving the wheels through the gearing mechanism. DC series motors are popular due to their excellent characteristics for the traction work. Next topic is the traction motors. So traction motors are coupled to the wheels of the locomotive through gearing arrangement. The traction motors use RDC and AC motors. So the DC series motor, and in AC the single phase AC series motor, three phase induction motor, and the linear induction motor. So these are the classification of the traction motor according to the AC and DC supply. The motor characteristics should meet the requirement of traction work. So the desired characteristics that the motor should process for the traction work are listed. So the first is the suitable speed torque characteristics. So the torque required at start or tractive effort required at start is high or maximum during the constant speed coasting. The tractive effort required is not high because kinetic energy is developed, and the tractive effort required is for overcoming the track resistance and gravity component. Thus the requirement is that motor should develop very high starting torque which should fall off at high speeds. Second characteristics of traction motor is the parallel running. So in traction work, usually more than one motor operates at a time. Hence these motors should be capable of operating in parallel. There occur a small difference in the rotational speed of our various motors because of uneven wear and tear of the wheels. This should not produce wide variations in the torque developed and current drawn by the various motors. Third is the voltage fluctuations. So in traction work, on account of heavy current, inrush at starting, considerable voltage fluctuation of supply line is a normal feature. Traction motor should be capable of withstanding voltage fluctuations without adverse effect on their performance. Fourth characteristics desirable is the temporary interruption of the supply. This occurs when section insulators and crossovers are crossed with the controller on. Motor should withstand these fluctuations without heavy inrush of current. Fifth is the overload capacity. The traction motors are subjected to the heavy loads which cause large rush of current. This may produce large armature reaction and bad commutation. The arcing produced on the commutator surface may extend over the whole periphery and flashover may occur. This is to be avoided at all the cost. Thus, motors should be capable of taking the heavy loads without flashover. Sixth is the self-relieving property. So as we know, torque is inversely proportional to the speed. So HP or output is proportional to the T into N. It is a constant. This gives motor a self-protective property against excessive overload. So seventh is the speed control. So amenability to the speed control. Motor should be amenable to simple speed control methods. It is the electric braking. So motor should be amenable to easy and simple methods of rheostatic and or regenerative braking. Ninth is the weight and size. So there is the limitation of weight and size. The traction motors should have high power to weight ratio. The physical size of motor depends on type of insulation employed. Traction motors are wound with class H insulation. Next is the robustness. So motors are subjected to the severe conditions. These motors should be robust enough to withstand such severe conditions, and the motor should be further provided with the mechanical protection such as the enclosure so as to prevent dust, dirt, water, mud. Last point is the high efficiency. So the motor should have high efficiency. So these are the desirable characteristics of the traction motors required to work properly. So basically it is type of the DC and AC. In AC we use AC single phase series motor, 3-phase induction motor and the linear induction motor. And the desirable characteristics of a traction motors are as follow. We have discussed in a detail. So these characteristics should be in the traction motors. Thank you.